first question. Find the real number a 0 to 1 that minimizes the integral xn minus a n mod when n is an integer more than or equal to 1, right? So of course the problem can be set at n equals to 24, but usually J wants to avoid this because that will give a hint that the question was generalized. Unfortunately, you can't use Leibniz rule here, which is a usual trick for JE problem, because the limit of integration is constant. Of course, we know since x is changing, so this quantity will be a function of a. So the idea is to find I and then differentiate to make it 0. So straightforward, I'll go with the solution. Since f of x, I can take this as x ka power n. And it's an increasing function for any n, right, between 0 to 1. So depending upon the values, x square, x cube, x to the power 4, you know, y equals x to the power half will be this, but mainly we are concerned with the integral values. Okay, so this is corresponding to root x. So for all these values, it's a strictly increasing function at nx n minus 1. So IA we can just calculate. We can break the limit at 0 to a and a to. The reason why we are breaking, because x ka power n equals a ka power n will happen at x equals n. So for x less than a, limit will, for x less than a, integral will open as this. For more than a, it will open. Now direct substitution tells us that IA value is 2n by n plus 1, e to the power n plus minus n plus 1. To find the minimum value, of course in this interval we'll find the derivative, which gives you this. And the only critical point is a equals half, because this quantity cannot be 0 exponential for any value of a between, let's say, half to the power n minus 1, okay, or 1 by 3 to the power n minus 1. So this is definitely non-zero, because exponential graph will, half to the power something graph will decreasing function. It will not touch 0 ever. Okay, so the only possibilities will be a equals half, since the derivative is negative on 0 to half and positive on this, will have a mean. Okay, so roughly I will be like this. So a equals half will have. Okay, so this is again a J relevant problem. For n greater than equal to 1, be an integer and denotes n as the set of all distinct value of this, where all these xi's, so x1, x2 till xn belongs to either minus 1 or 1. In the first question is you have to find the sets a1, a2, a3, a4. So let's understand the meaning of a2. So if I'll put n equals 2, a2 will becomes 2x2. So e2 is x1 plus 2x2 for n equals 2. Now x1 and x2 can take minus 1 or plus 1. So we have only 4 possibilities: minus 1, 1, minus 1, minus 1, 1, 1, and 1, minus 1. And that gives how many distinct values? So we have minus 1 from the first, 3 from the second, we have minus 3 from third, and 1 from the fourth. We generalize this. So how many total number of n is there? Like number of elements in n for each n that are equal to 1. One thing we can see, like we can find the pattern as well. A1 is having 2 elements, A2 is having like 4, A3, 4, 7 elements, A4 is 4, 8, and 11, and so on and so forth. So you can clearly see, like you can observe some pattern based on their common difference, like their common difference is 2, 4 minus n is 3, 4, and this. And if I define sum to be 2 plus 4 plus 7 plus 11, okay, their second order term will be constant. So hence with basic sequence and series, we can easily find 1 plus n into n plus 1 by 2. So here is a good problem, and this is a challenging one. So let's try. Clearly we can graph this both function. So for each x, let fx equals to the smaller of the two values. So it's basically minimum of these two, right, for a particular x. So what does it mean? Let's say if I keep x equals 1. Okay, so the expression will turn out to be 1 minus a square, and that will be a plus 1 square. So out of this both we have to find the minimum. Now again, minimum of this both expression will also depend on the value of a, right? So let's say if a is 0, then it's minimum of 1 comma 1, so which we can call 1 because they are equal. For a equals 1, minimum is clearly between 0 and 4, so it is 0, so like this. So it's a function both of x as well as a. So that we have to take care. Understanding of a problem is must, okay, before we try to attempt this. So let's try to graph x minus a whole square and x minus a minus 2. So x minus a whole square will be roughly like this, and the other way x minus, so it will go at a plus 2 comma 0 vertex, and hence other graph will be something like this, right? So what about minimum of these two functions? Clearly you can see the minimum of 2 is going to be the curve which I am using in this curve. And this will happen for any a because a itself can slide. Okay, so a is changing. Sorry, basically a is restricted between -2 to 2. Yeah. So here a itself can change between this interval because under that interval we want to analyze the function. So now we can take cases, of course. So first case when a is from 0 to 2 is positive, then fa can be defined as 0 to 1 x minus a whole square dx. So how do we analyze this? When a is between 0 to 2, so this itself will go from 2 to 0, and the other thing is going to go to 4, right? So we are only interested in this chunk between -2 to 2. So between 0 to 2, the minimum value will be of just this value because we have just single graph, and this is more. Okay, so like this will end. Okay, so let's take the second case when a is -1 to 0. Let's say if I keep a equals -1, the first graph will go to -1. The second graph is 1 comma 0 vertex wise, right? Okay, so the graph is not up to this scale, so the point of intersection, everything we just calculate, it might not be on y-axis. Of course, under this case from -1 to 0, the minimum one will be this. This is a case corresponding to a equals -1. But now for a equals 0, still the other extreme value that I'll get is, it will be x square. So a equals 0 will be vertex over here, and the other guy is x minus 2 whole square. Okay, so it's at 2. So for a equal to 0, the minimum value between -1 and 0 is gonna be this curve, right? So again we can see the minimum value keeps on changing depending upon the value of a. So hence how fa, the function, will open in this interval. We can break this from 0 to a plus 1, the point of intersection of this graph, like both of them at some particular location, x minus a whole square dx plus a plus 1 to 1 x minus a minus 2 whole square dx. This step you can convince yourself because for any a randomly between -1 to 0, this is the extreme situations I have drawn, right? And a plus 1 to 1. F of a is, remember, 0 to 1 f of x. Fine. So this basically represents 0 to point of intersection of these two curves. So logically what's happening is x minus a whole square is going to be like this, and x minus a plus 2 whole square is going to be this. So 0 to 1 is basically this area of bounded region. So the point of intersection is a plus 1, hence we'll break the integral from 0 to a plus 1, first part, and second part. Now this calculation you can simply do quickly. Over 3 from 0 to a plus 1 minus x minus a minus 2 whole cube by 3 from a plus 1 to 1. And that gives us minus a square minus a plus 1/3, which is 7 by 12 minus a plus half whole square. Okay, so this is the expression that we are getting in this window. Now we are left with one more window. So case 3, when a belongs to minus 2 to minus. Now clearly again we can see at x equals a, and we have this 0, a plus 2. So this time minus 1 to 0. The area will be again 0 to 1, that function. So this time the area is going to be 0 to 1, which is this bounded region. And the values of fa is 0 to 1 x minus a minus 2 whole square dx, which evaluates to a square plus 3 plus 7 over 3 and a plus 3 over 2 whole square plus 1 by 12. Now combining all the three, we can basically get a feel of the graph of f of a. So let's see how f of a changes with a. As we can see, roughly at minus 3 over 2 we will get. So this is just a rough picture, right? So roughly we'll have graph like this, right? So at 2 we'll get minimum. Here we have minus 2, at 0 possibly 7 by 12. So if you analyze all the values, the maximum value of f2 is coming to be 7 by 3. Because now for this quadratic in the remaining constant range, we can find the maximum minimum values, which is quite an easier stuff now. And the minimum value that we'll get will be at f of half, the point of minimum, minus 3 by 2. And both these values, the minimum value is 1 by 12. Okay, so function is 1 by 12 and the maximum is 7 by 3. Let's move to next question, and this was definitely a challenging. Okay, so let's understand the problem. Lattice point, for example, 2, 1 qualifies, whereas 2, 1 by 3 is not a lattice point. So both coordinate has to be integer. So these are some of the lattice point which is shown. Let's take a line of slope to over 5. So that means we are going 2 unit up and 5 unit. So 1, 2, 3, 4, 5. Run and 2 right. So clearly, if we'll draw circles on either, on each of this lattice point, with radius r, if I take radius to be 10 to power, let's say minus 20, then it's too small. Of course, a line with slope 2 by 5 is intersecting this circle over here, but it might happen like if the radius is too small, this line, let's say, still it is having 2 by 5 slope, but it's not intersecting any of the circle. So if the question is clear, you can just give a thought process of how to find the minimum value of r. So there must be a value of r which is more than r minimum for which this will have. Because if I'll take r to be too large, okay, of course we feel like 2 by 5 slope will be cutting it, and so that gives a feel like, yeah, there must be a threshold lower bound for the radius of the circle. And here we go. We can start again in JE style. Let's write a general equation of any line having slope 2 by 5, which is 2x minus 5y plus or minus k. So here k is a constant. I have to use minus k maybe for the sake of simplicity of calculation. Now, if I take up, let's say, this line cuts the circle with a radius r, and let's say the center of a random circle in lattice point is m, n. So what will be the distance? 2m minus 5n minus k. Distance of center from this line is equals radius 2 square plus minus 5 square. In fact, that should be less than equal to r, right? Less than equal to r. So if distance of a point from the line is less than equal to r, definitely it's going to cut it. In the special case, it will be tangential. And this simply varies to 2m minus 5n minus k is less than equals root 29r. So now we can look for a condition. We want to search for a special value of r such that for any ordered whole number m comma n and for any value of real values of k, this expression should hold true. Now we can tell a little bit, we can play with this expression 2m minus 5n because m comma n is still an integer. For the sake of simplicity, of course, I'm drawing in on positive on first quadrant because the same thing, the lattice distribution is uniform, so it doesn't matter. So 2m minus 5n, let's say if m is 1 and 5 is 2, m1 and n is 2, we'll get 2 minus 10, which is minus 8. So yes, this can give a value of minus 8. Can we get any value? Let's say, can we get a value of 1? So let's give a try. Of course, is 6 minus 5 can give. So m is 3 and n equals 1. Let's experiment more. Can we get a value of 2? Because we need to have a control on this expression, 2m minus 5n, right? Yeah, it feels so, because this can be maybe 2 will come from what? 6 minus 4, that's not possible. 10 minus 8, that's not possible. 12 minus 10. 12 minus 10 is 2, right? So m 6 and n equals 2. So like this, now my claim is we can get actually any integer from 2m minus 5n. So this can give me any integer, whatever you want. How to prove this claim? One way will be basic division lemma, because SCF of 2 and GCD of 2 comma 5 is 1. So from here, can you relate? If GCD of 2 comma 5 is 1, then 2m minus 5n can give me any values. The other way of looking at this, you can think m, let's say, if 3 times of some integer or natural number, let's say, because we are in first quadrant. And if I choose n as, just n. So under this condition, 2 into n minus 5 into m, or 2m minus 5n. So under this condition, 2m minus 5n will give me simply 6n minus 5n, which is n. So I can express any n in format of 2m minus 5n. And that's a good point. So now I know 2m minus 5n is just any natural numbers or any integer to start with. So the expression boils down to this is less than or equal to root 29. Now what does n minus k represents? Clearly k is a real number because it's intercept of the line. So now on this real number line, for any real k, there is an integer point n such that the distance between point k and real number line, let's go to the real number line and check what this integer point will look like. So we have 0, 1, 2, 3, minus 1, minus 2, minus 3. Again, this is uniformly distributed. If I pick up any number, let's say k, either k itself will be an integer or k can be fraction. In either case, the minimum distance between any integer point with that number k will definitely be, so n minus k value will definitely be less than or equal to half. Why? Because let's say exactly if the number k is in middle, so this gap will be half, magnitude wise, right? If k is on either of the sides, if it's here, so this distance is less than half, because the minimum distance in these two I have to take. Okay, so if you are closer to 0, then of course minimum distance will be taken from 0. If you are closer to -1, so this quantity will be less than or equals half. And I know this has to be less than or equals root 29r. So if this root 29r is always more than the value of mod n minus k. So it must beat the minimum value of root 29r must beat the maximum value of n minus k mod, right? Because this quantity is more than this. So even if when the LHS is at its maximum awkaat, still root 29r should beat it. So root 29r must beat even the maximum value of mod n minus k, right? And what is maximum value of mod n minus k? It's half from this expression, and that can be written when exactly you are in middle. That will be root nr. This implies r is more than equals 1 by 2 root 19. So it shows r is more than equals this, which gives the value of r min is root 29 by